Hello friends, so far we have discussed about several global issues of environmental nature, that is the pollution which causes environmental issues at the scale of global level like ozone hole or global warming, climate change. Today we will discuss in that series the acid rain. And acid rain is basically regional environmental issue, but it is also can be termed as global environmental issue because of its like continental nature, or in different countries it is spreading. So we can call it as a global regional environmental issue, which is very important. So today we will discuss about what is the acid rain and what causes the acid rain, then a little bit timeline of the acid rain history, and pathways which are responsible for the acid rain, then different forms of the acid rain like wet deposition, dry deposition, those kind of things we will see. And then we will see like how to measure the acid rain and its effects, and how do we monitor, or different kind of monitoring networks which are responsible for monitoring the acid rain, so that it can be known about its intensity, and in which area it is more and how can we control it, and then how to reduce the acid rain. Basically those kind of measures we will discuss, and at last we will conclude. So when we talk about what is the acid rain, so you can imagine like raining, and the pH of the rain which is normally less than the 7 because of CO2 present in the atmosphere and that weak acid of H2CO3. But if the pH of the acid pH of the rain is in the range of like 4.2, 4.4, means less than the 5, then we can call it as a acid rain, because that signifies or it indicates that maybe some elements or some compounds or some chemicals like sulfuric acid or nitric acid, which is because of presence of sulfur dioxide and NOx, and when they react with the moisture of the atmosphere and ultimately create these acids. So those acids become part of the these droplets. Okay. So in the precipitation it comes down, and pH of the rainwater changes. So then wherever it meets, like if it joins the water bodies or it falls on the surfaces, then the pH of the soil is also reduced, and it can come in several forms, like not only the rain, but it can come down in the form of snow, in terms of the fog, or hails, or even dry deposition like particles which are of acidic coating, those kind of things, and they can come down, and that is why this acid rain occurs. This phenomena of acid rain is something like that, and the causes or the responsible reasons for this is basically those kind of emissions of the air pollutants like oxides of sulfur or oxides of nitrogen, which are emitted in the atmosphere because of several anthropogenic activities, where we burn different kind of fuels like the coal burning power plants, where coal content is sulfur, then sulfur goes like sulfur dioxide in the air unless we really capture it completely. So sometimes those capturing instruments are not 100% that kind of efficiency, and some sulfur oxide is there, and several sources may be there, not only the thermal power plants based on the coal, but several other sources can be there of the sulfur dioxide. The NOx emissions can come from several other sources like automobiles or wherever we are burning the fossil fuels. So those kind of emissions which are responsible for these particular acidic gases which comes into the air, and then they react with the atmospheric moisture, and create these sulfuric acid and nitric acid. Well, a small portion of SO2 and NOx that causes acid rain is from natural sources also, and not only the small, but quite large amount comes out of volcanoes, right. Then most of these emissions of sulfur dioxide and NOx, they come from fossil fuel, as I said, because of anthropogenic activities. Wherever we are burning fuels, we are generating some sort of emissions of oxides of nitrogen and oxides of sulfur. Well, these burning of fossil fuels which we do in electricity generation, okay, so they are responsible like 2/3 of SO2 and 1/4 of NOx in the atmosphere, it is estimated that they come from electric power generator facilities. Okay. Then vehicles and heavy equipments also burn lot of fuels, and they are also responsible for such gaseous emissions. Manufacturing, oil refineries and other industries, they are also responsible for emissions of these gaseous components. Well, when we talk about pathways for the acid rain, basically when these emissions are released into that air, okay, like these the emissions of SOx and NOx etc., then they get converted into calcium sulphate or magnesium sulphate or nitrate of something. So, you can say the gaseous components can be transformed into particulate nature or solid form. So, these particles can also be responsible for transporting from one place to another, or these gaseous components can react with the moisture in the atmosphere. So, all these phenomena is basically responsible for this generation of the acid rain, and then it gets transported in the downwind direction, and particles can get deposited as the dry deposition, and other these sulfuric components or nitrate etc., they can get deposited as wet deposition also. So, both wet deposition and dry deposition of acidic components are responsible for the acid rain, and they can cause harmful effects or negative impacts on whatever surface they come in contact to, like whether soil, whether forest or streams or lakes, because they change the pH of those particular ecosystems. Okay. Now, if we talk about the history of acid rain or the timeline when it was noticed and how it increased. So, basically the first observation of acid rain was recorded in the mid 19th century in Europe, because in Europe lot of this coal burning activities took place, and the signs of this acid rain was noticed, like deterioration of the leaves. Okay. They were noticed in the forest, like Black Forest of Germany was completely devastated because of these acid rain, which occurred because of emissions of sulfur and other oxides in England, and it was later proved, and then treaty was signed between Germany and Great Britain, that those emissions must be curtailed, so that these black forest deterioration because of acid rain can be stopped. So, those kind of relationships or historical events are there. In 1872, an English scientist, Robert Angus Smith, he introduced this term of the acid rain, as he noticed this acid precipitation damages the leaves of the plants and the forest. In 1970 onwards, the severity of the issue increased further, because acid rain increased in several parts, and after 10 years of continuous national acidic precipitation assessment program of the US Congress, when US Congress noticed this as per basis of this program's observation. So, the US Congress passed the Acid Deposition Act in 1980, and further this was enlarged as a monitoring site network for dry deposition and the effects of acid rain on monuments or freshwater bodies or terrestrial ecosystems and buildings. So, those were also covered after this act was enacted. Well, when you look into further down the timeline, then according to this particular program which we discussed, the first assessment report published in 1991 on acid rain, and it was noticed that about 5% of New England's lakes were acidic in the US. Okay, in that region of the New England in the US, and the issues such as changes in the biochemical patterns of the soil, characteristics or freshwater bodies, and damages to the man-made structures were also observed, and they were associated with these acid rain precipitations. Okay. By 1990, the US Congress had passed amendments to the Clean Air Act of 1970, and this was implemented aiming to decrease the total emissions of sulfur dioxide by 10 million tons. So, those kind of very big targets were aimed to achieve. Similarly, several programs were carried out since 1990 to reduce NOx emissions also, because not only the sulfur dioxide emissions, but NOx emissions are also equally responsible for the acid rain. So, the emissions of the NOx from factories and automobiles, they were also targeted to get reduced. By March 2005, the US EPA, that is Environmental Protection Agency of the US, issued Clean Air Interstate Rule (CAIR) to reduce the pollution from power plant emissions from one state to another. So, those kind of transboundary pollutions were tracked, and it was decided that how to control those emissions in other states, which also affect the states in the downwind direction. Well, when we talk about the forms of acid deposition, in what way they get deposited. So, we briefly touch that wet deposition is there, dry deposition is there. So, if you talk about wet deposition, basically it is commonly known as the acid rain. Basically that wet deposition is the acid rain, because precipitation is coming and the pH of that acid rain is less than 5, it is around 4 or so, and that is the particular acid rain. But dry deposition may also take place. Okay? Dry deposition may also take place, and that is because of acidic particles. Okay? And then even gases also, even if it is not reacting with the moisture, and the gaseous component of the acidic nature and the particles of the acidic nature, they get descend because of gravity, and then this dry deposition process happens, and they can get deposited on surfaces of water bodies or vegetation or buildings, and this phenomena becomes quite quick counterintuitive. Sometimes we do not feel that this may happen so quickly, but it happens in the nature quite quickly. When we talk about like measuring of the acid rain, so basically the phenomena of pH is the important. The pH of this at the log scale, this H plus ions concentration, how much it is present in the solution. So, that is the basic pH. Okay? pH is the indicator of that those H plus ion or hydrogen ions present in the solution. So, the acidity and alkalinity are measured using this at the pH scale, for which we assume that 7 is the neutral. Okay? And the lower the pH of a substance less than 7, the more acidic it is known as, and the higher the pH beyond the 7 like 8, 9, then we call it alkaline. Okay? So, those particularly definition of acidic and alkaline solutions are there, and the normal rain has a pH about 5.6 or so, it is not 7. Okay? The reason is because this slight acidic is due to this carbon dioxide which is present in the atmosphere, and it dissolve into this moisture, this rainwater, forming weak carbonic acid H2CO3. Okay? And the acid rain usually has a pH between 4.2 to 4.4. So, means up to 5.6 you can't say that this is acid rain or so, this is natural rain you can call it. But if less than 5 the pH is there, then you should be alert that there may be some sources of acidic nature of gaseous components which have reduced the pH of the rainwater, and that is because of the presence of like sulfur dioxide, NOx, etc. So, you can see at the pH scale, basically it has been shown for all kind of things like battery acid pH 0, lemon juice pH 2, okay, soda has pH 2.5, acid rain 4.3 or so, distilled water pH 7 because neutral, then blood has pH around 7.4 or so, sea water has around 8.1 very alkaline saline water. Then this baking soda has pH of 9, ammonia has 11, bleaching powder, this bleach has the this 12.6, liquid drain cleaner has pH 14. So, means different solutions have different kind of pH according to the nature. Well, the very easy way to kind of look at that whether this pH is lower than 7 or higher than 7, litmus test is there. Litmus, that is basic thing which you might have seen in the chemistry lab. Okay? When this paper turns to the red, the substance is acidic, as we know, because it changes the color, and when it turns blue, then the substance is basic. Like if it is pH is less than 4, then it turns to the red, and when pH is more than 8.3, then it turns into the blue. Those kind of things are there. So, this National Atmospheric Deposition Program was launched, okay, and National Trends Network was established for measurement of wet deposition in the US and nearby areas. Okay. So, this was basically conglomeration of more than 250 monitoring sites throughout the US, Canada, Alaska, Hawaii and US Virgin Islands. So, very large area was covered to monitor the these whether acid rain is occurring or not, right. So, unlike this wet deposition, if we talk about the dry deposition, then dry deposition is difficult and expensive to measure, because acid rain pH you can easily measure, but dry deposition measurement is more expensive, but still there are programs like to estimate the nitrogen and sulfur pollutants in terms of dry deposition through clean air status trends network. Okay. And this air concentrations are measured by this particular program at more than 90 locations, because it is expensive. So, the number of locations is much smaller than the number of locations, like it is around 250 networking sites, here only 90 locations. Okay. Now, if we talk about the effects of acid rain, then basically the effect can be on the ecosystem, effect can be on the materials when it come into contact with the materials, effects can be on the visibility also, and effects can be on the human health or animal health. Okay. So, we will see one by one. Like if we talk about the ecosystem, then this ecosystem is nothing but the community of plants, animals and other organisms along with their environment, including air, water and soil. So, a particular integrated kind of thing is there So, everything is in ecosystem well connected with each other, right. If something happens to one part, if it is harmed, then the other parts can get affected negatively, because they are interdependent. Okay. Like one in the food chain, if one animal or plant is destroyed, then the whole chain can be completely disturbed. So, that is the characteristic of ecosystem. So, when we talk about the effects of acid rain on fish and wildlife, you can see different kind of fish has tolerance limits to different levels of pH. So, the ecological effects of the acid rain are most clearly seen in the aquatic environment, such as streams, lakes and marshes, where it can be harmful to the fish and other species. Like you can see the frogs up to falls, these critical pH levels, after that it is very negatively affecting those particular species. When we talk about some lakes, because of this acidic nature, aquatic life get disturbed. Like there is one example of one lake in Sweden, and it is quite acidic and no longer able to support the fish life. So, aquatic life is completely disturbed because of this acidic nature of the water due to this acid rain. Well, some types of plants and animals can tolerate acidic waters, but others may not, because acid sensitivity may be different. Okay. So, they can get lost because of these pH declination is there in the environment, okay, and then they can disturb the complete ecosystem. Generally, the young and most species of the most species are more sensitive to acidic environments than adults, because their this tolerance limit is very low. At pH 5, most fish eggs cannot mature. Some adult fish die at lower pH values. So, this is kind of drastic negative impact on the aquatic life, particularly fish. Okay. When we talk about like fish or animal which can tolerate moderately acidic water, the plants or phytoplanktons like fish dependent on, they can be damaged, or their losses can be in huge quantity, and then they can indirectly affect the fish population, because then there is no availability of the food. Similarly, in animal kingdom also, if the lower level animals which are not very tolerant to the acidic environment, if they are lost, then the complete chain get disturbed, and the higher in the that ladder food chain, if higher level of animals may get also affected. For example, frogs have a critical pH around 4, but the these mayflies they eat are more sensitive and may not survive at the pH below 5.5. So, if those flies are not available, then frogs may also die even if the pH is not up to the 4. So, at 5, if it is food is not available, then frogs will also be dying. Well, these on the plants and trees, the negative impacts are there because of region, they can destroy these leaves, and photosynthesis is completely deteriorated, and even there is this disturbance of the minerals in the soil. So, the growth rate is disturbed of the plants and trees. So, that is again negative impact of the acid rain. And at high elevations like in mountains, etc., these acidic fog and clouds may deplete the nutrients in the tree leaves, resulting in brown or dead leaves, and because of that this photosynthesis is completely disturbed, because they absorb very less amount of sunlight when there is no green cover, and there is no sufficient amount of the leaves. Okay, you can see like in Black Forest in Germany, this kind of negative impact was there. This green color was destroyed. So, food production by these leaves was completely harmed, disturbed. And you can see in this Smoky Mountains, Great Smoky Mountains in USA, these trees were affected because of acid rain. So, their leaves were destroyed, and again the photosynthesis was completely disturbed. Well, but there may be some other issues like buffering capacity of different soils are different because of their thickness, because of certain minerals available in those soils. So, if buffering capacity is there, then sometimes that negative effect on the plants may not be translated in that form, because that soil can do buffering kind of activity. That means they absorb that acid, and they that negative impact is not translated to the plants, etc. But it depends upon the quality of the soil, and different minerals or organic materials, etc., or calcium carbonate, etc., present in the soil, which can neutralize the acid rain. So, those kind of buffering capacity may be available, but it depends upon the location. Like in areas such as mountainous parts of the northeast United States, the soil is thin, and this lacks the ability to adequately neutralize the acid in rainwater. So, negative impact is more there. So, as a result, these areas are particularly vulnerable, and the acid rain accumulate in the soil, streams and lakes in those particular areas. Okay. When at sometimes this episodic acidification may also occur, because like snow melts, and suddenly it takes with it lot of acidic water to particular lakes, and then the pH drastically reduces for some small period, but that small period may be quite disturbing for aquatic life in those particular ecosystems. So, episodic acidification may also occur, and then again other rain water neutralize this acidic component, and then again life thrives, but that particular disturbing period may be quite problematic for aquatic life. Okay. When we talk about the impacts of acid rain on materials, then you may visualize about different monuments which are deteriorated, whose surfaces are deteriorated by these acid rain particles and acid rain itself, like sulfuric acid, etc., because the statues or the building materials of the stone, and they can get affected very severely. Okay. These acidic particles may corrode the metals, or they can cause paint and stones to deteriorate more quickly because of their chemical reactions. So, like if you talk about whether Taj Mahal in India, or St. Paul's Cathedral in London, or this Westminster Abbey in England, and the Sphinx in Egypt, or the Statue of Liberty in the New York, or the cathedral in Cologne in Germany, all those their surfaces got deteriorated because of these acidic component in the air and in the rainwater. Okay. So, that way also you can say that this is global issue, otherwise it is local and regional issue, the acid rain, but in that way it is kind of global issue nowadays. The consequences of this damages can be costly, because then we have to repair them and or replace them, and sometimes these monumental, they are kind of very precious, because it is very difficult to recreate them, right. So, not only the maintenance related, but their value, that historical value or their cultural value, we cannot convert into any monetary terms, and that loss may be for whole time, and it is not affordable. So, we should be careful that in those areas we should stop these kind of phenomena which is known as acid rain. So, that whatever emissions which are affecting precipitation in those areas, they must be curtailed, particularly the emissions of SOx, NOx, etc. Well, in terms of visibility also, there are issues, because these particles like sulphate etc., they are reflecting light, and sometimes NOx emissions, they also play as a precursor role to produce the ozone, and smoke is created in those areas. So, visibility is reduced very significantly, and those hazy and difficult to see kind of days are there because of these particles and because of smoke. And again, these acidic components in the air, they participate in these kind of visibility problem. Like this can affect even those enjoyment of national parks that we visit for the scenic beauty. Otherwise, if they are clear, then it is beautiful. If it is hazy, then we can't see the beauty, that aesthetic value of those particular locations may be deteriorated. Okay? And the acid fog, particularly particles of sulfur dioxide and sulfuric trioxide, which reduces visibility around 50 to 70% in eastern USA, it has been observed. Well, then when we come to this human health aspect, then again because of these toxicity nature of sulfur dioxide and NOx etc., because when we inhale, they damaging our respiratory system, and those particles, those secondary aerosols etc., because of these sulfate and nitrate particles, they are again part of these respiratory related issues. Okay. So, those people who are having health issues like lung related problems, bronchitis related issues, if those particles are present in the air, then they can further aggravate those kind of problems, they can damage in even the lungs etc. Okay. So, those are the health issues. Now, if we talk about that, how to monitor the acid rain. So, you can see these like there may be containers which can get these acid rain water, rainwater, which the pH of which we can observe in the laboratory. Similarly, there may be other container which can get these dust particles, the dry particle deposited. That way we can really know how much acidity is present in that rainwater. But nowadays these are the traditional way which I was talking, but they are now sensor based electrical resistance which are used worldwide nowadays, which can give the quick results basically. And if you want to reduce the acid rain, then naturally we have to cut the the burning of the fossil fuel, or we have to switch the fuel, or we have to scrub. That means we have to control those emissions of SOx and NOx kind of gaseous exhaust gases. Otherwise, if they go into the atmosphere, then they will result into the acid rain. So, there may be two broad categories of solution, like either switch the fuel which are not emitting sulfur dioxide, NOx etc., or if they are emitting, then control them, scrub them, remove them. Okay. So, the fuel switching includes like limiting the use of sulfur containing fossil fuels, for example coal kind of things. Okay. And then switching to nuclear power generation, or using renewable energy sources like wind, solar, air, geothermal energy, they really help us because they are not emitting any kind of these emissions which cause the acid rain. Okay. Then the use of solar batteries, fuel cells, natural gas in electric motor vehicles promotion, all these are in that direction to remove or to reduce the emissions of SOx and NOx. Use energy efficient boilers and using those filters which can scrub or catch those sulfur and nitrogen related effluents from the vehicles or industrial emissions. They are part of that reduction of the emissions of NOx and SOx. In Europe and North America, people are also using very tall stacks like 400 meter or so that the local pollution get reduced completely, because it goes up to very high levels of the boundary layer, and when it get diluted in the atmosphere, then at least in the local region it is not there, but it is kind of transferring the problem from local to regional scale, you can say, because ultimately it will come down whether in the form of rainwater or dry deposition. Well, so in conclusion we can say that because of these fossil fuel burning and increase in the emissions of SOx and NOx, this acid rain phenomena occurred since the 19th century and it is increasing day by day, and the coal combustion is the primary source of sulfur dioxide. So, we need to reduce this coal combustion and shift our energy needs to other sources of renewable nature. Vehicular emissions and varied fossil fuel based power generation, they contribute NOx emissions. So, if we go for those kind of energy sources like electric vehicles etc., in terms of reduction of vehicle emissions, that is also a good strategy. In most countries across the globe now, acid rain has become a major local or regional scale environmental issue. So, every country needs to make sincere efforts to reduce the emissions of SOx and NOx kind of emissions which are responsible for acid rain. So, the acid rain can be reduced if we can control the emissions of those cause factors like SOx and NOx. That is the basic thing in this particular lecture. So, you have seen in this lecture that what are the causes of the acid rain and how can we deal with it. So, I hope you like this lecture in that term, and this is not only the local problem, but the regional scale problem, and at the global network also you can see, because in most of the countries some sort of the monuments are getting affected by acid rain. So, this is in that sense it is also the global issue. Okay, so, this is all for today. These are the references for additional information for you. You can go through in the free time through these references. So, thanks to you, and see you in the next lecture. Thanks for your kind attention. Thanks a lot.